You hear about quantum computing all the time, right? It's this incredible technology that's supposed to solve humanity's biggest problems, designing life-saving drugs, creating brand new materials. It's a huge leap into a new reality of computation. But what if that incredible power has a hidden darker side? What if the very rules that make it so powerful also make it dangerously vulnerable? Okay, let's get into it.
Just to give you an idea of the speed we're talking about, look at this number, 430%. That's the projected jump in quantum patent publications in just a few short years. This isn't some sci-fi dream. It's a full-on tech race happening right now, with billions of dollars and the world's brightest minds pushing it forward every single day.
So, before we can get into the risks, we've got to understand the revolution itself. What exactly is this quantum leap we're all taking?
Well, this slide really gets to the heart of it. The computer or phone you're on right now, it thinks in bits. Simple, reliable, either a 0 or a 1. It solves problems step by step, very logically. But quantum computers, they use qubits, and this is where things get weird. Thanks to something called superposition, a qubit can be a 0, a 1, or both at the same time. And with another trick called entanglement, you can link these qubits together. Their fates become intertwined. This lets them explore a huge number of possibilities all at once. And here's what that new way of thinking actually looks like. It's not just a quantum machine working alone. It's more like a dance between the quantum processor and a classical computer that helps guide it. It's this unique partnership that lets quantum computers tackle insane problems in medicine, science, and finance. Stuff that even our most powerful supercomputers today just can't handle. And this isn't all happening in some secret basement lab. We're talking about the biggest names in tech: IBM, Google, Microsoft, Amazon, plus a ton of brilliant startups. They are all pouring money into this. And get this, they're not just building the machines, they're making them available on the cloud right now for anyone to use. The future is already here. Okay, but here's where the story takes a turn. That same quantum weirdness that gives these machines their incredible power, well, it also creates a completely new, uncharted territory for security threats. It's an attack surface unlike anything we've ever seen before. And I'm not just talking about new kinds of software bugs. We're talking about vulnerabilities in the very physics of the machine. The physical qubits are incredibly sensitive to their environment. Even the special software that translates our ideas into quantum instructions, it all creates new weak points an attacker could go after. So let's use this map as our guide. You can see the threats exist at every single level. Up at the top, someone could steal a company's secret sauce, their quantum algorithm. In the middle, a hacker could create a malicious compiler to secretly mess with the instructions. And down at the very bottom, you can physically manipulate the hardware itself through things like crosstalk, where one qubit's operation accidentally messes with its neighbors. I know, this all sounds a little abstract, so let's look at a concrete example of how someone could actually pull off a real-world attack.
It's the million-dollar question, right? But forget guessing passwords. Hacking a quantum computer is about exploiting the very laws of physics that make it work.
Check this out. This diagram shows a really clever and sneaky attack on a specific type of quantum computer. In a cloud setup, you might have multiple people sharing the same machine. An attacker, the adversary here, can run a program that does nothing but move ions back and forth over and over again. Think of it like a noisy neighbor who won't stop slamming their door. All that vibration and energy bleeds over and messes up the delicate work the victim is trying to do. And don't just take my word for it. The research paper is pretty clear about the impact. This isn't a small thing. This constant shuttling literally pumps energy into the whole system, which makes the victim's calculations less and less reliable. It introduces errors not through a software bug, but through physical interference. And this chart shows you exactly what that damage looks like. See that big black bar on the right? That's the chance of getting the correct answer, 111, when everything is normal. Pretty high, right? As it should be. But as the attacker starts to interfere just a little bit, you see that probability of getting the right answer just plummet. And the chance of getting a wrong answer shoots up. The computer doesn't crash, it just starts to lie to you. So the threat isn't just technical. It turns out the very laws we use to protect our ideas, well, they were written for a completely different world, and they are struggling to keep up.
So this brings up a totally different kind of problem. Let's say you invent a revolutionary quantum algorithm. Awesome, but how do you protect it? How do you prove you own an idea when the patent office looks at it and just sees a bunch of abstract math?
This is the legal catch-22 that so many innovators are running into.
You come up with this brilliant idea, you file for a patent, and then you get rejected. In a lot of places, like India with its Section 3K, an algorithm can just be dismissed as a mathematical method, making it impossible to patent. Your world-changing idea is just out there, unprotected.
And this table really lays out the tough choices. A patent would be great, it's strong protection, but it's hard to get and it might even expire before your idea is ready for the market. You could copyright the code, but that only protects the exact lines you wrote, not the core concept. Then there are trade secrets. They can last forever, but if someone else figures out your idea on their own, you've got no protection. There really is no perfect solution right now.
And that brings us to, well, the elephant in the room. Forget about stealing one algorithm. A powerful enough quantum computer could break the encryption that protects our entire digital world. We're talking banking, secure communications, government secrets, everything. One estimate says a machine with just over 4,000 qubits could crack standard RSA encryption in 10 seconds, a task that would take a normal computer literally trillions of years.
Okay, I know that sounds pretty grim, but it's not all doom and gloom. The same brilliant people building this technology are also in a race to build its defenses. We are, right now, building the quantum fort.
And the effort is happening on two parallel fronts. On the technical side, people are coming up with clever tricks like circuit obfuscation to hide what an algorithm is really doing, and even physically adding buffer qubits to shield the important calculations from that noisy crosstalk we talked about. And on the policy side, governments are scrambling to create new quantum-proof encryption standards and are starting to ask the hard questions about how we need to reform our patent laws for this new era. Which leaves us with the final, critical question. This technology is moving at an absolutely blistering pace, with new breakthroughs all the time. The race is on, not just to build a better quantum computer, but to build a secure quantum future. So the real question is, can we build the defenses as fast as we're building the weapons?